Hello students and welcome to our new unit. This is unit 15. The topic is acids and bases. And some of the things we're going to cover are listed out here on this outline. In this first portion, we're going to do a quick review of acids and base properties. Now, in our household, we might always find things that contain acids in them. Those that we can taste are typically sour to the taste. Acids can dissolve many metals, and they also have an interesting property. They change blue litmus paper to red. We'll see that in a few moments. Bases, on the other hand, those that we can put in our mouths, will taste bitter. As a matter of fact, there are many bases that are actually products of plants that are made to fight off pests. They feel slippery to the touch, like soapy, and that's because essentially soaps are actually bases. And they have the chemical ability to turn red litmus paper blue. Now, I realize that many of you have studied this in previous courses, and you might have it fresh in your memory, but I realize also that many of you have not touched this subject in a while. So I'm going to take the liberty of walking us through a series of demonstrations of chemical properties of different substances, and then we'll analyze it. If you feel comfortable with your understanding of electrolytes and conductivity tests and litmus paper and that kind of stuff, then feel free to skip this whole section and just jump ahead to the next one, okay? Hello students, Dr. DA here. A lot of background noise. My face is totally covered, so you can tell that at the time of this video, it is the year 2020, the year of the pandemic. But I'm here in the lab to do a few demos for you so you can better understand the working of acids and bases. What I have before you here are several solutions of items that we commonly find either in the lab or even in our household. And what we're going to do is we're going to probe them with this conductivity tester. Notice that it has a light bulb and it has two electrodes. Of course, they're covered so I don't electrocute myself. And it's plugged in, but right now the light bulb cannot turn on because there is no connection between the two electrodes here to close the circuit. And as expected, if I test this against distilled water, in other words, water from which all of the salts typically present in tap water and the chlorine and everything have been removed, of course, I don't get any conductivity. However, if instead of that I have a solution of salt, sodium chloride, our good friend, when I probe it with this, wow, the light goes on very bright. So what I'm going to do is I'm going to test other things here. In between tests, of course, we want to clean the electrodes. So I'm going to rinse them out here. All right, there we go. And so I'm going to be doing that in between each test. So here is sodium hydroxide, NaOH, which in very concentrated form would be Drano in your house, but this is more dilute. Let's see what happens when I probe it with my conductivity tester here. Wow, again, a very bright light, very good. So that means that there is something in there that similarly to sodium chloride causes the solution to conduct electricity. Of course, you know from the formulas, NaCl, NaOH, that we're talking about ions. Let's see HCl. HCl, hydrogen chloride, is typically a gas, but when you dissolve it in water, we call it hydrochloric acid. So let's see what happens in this case. There you go, very bright light, which means that even though HCl is a molecular compound, when you put it in water, it causes water or the solution to conduct electricity. Now, one common element or one common item in our household, I should say, is vinegar. Let's try vinegar out and see what happens. As you can see, the light bulb also turns on. It's a little dimmer than the one we had with the HCl and the NaOH and the NaCl, but it still lights up. Let's try another item. In the meantime, I'm going to be rinsing out our electrodes. All right. And let's try out what happens when we put it in ammonia. Now, this is an ammonia solution, of course, and actually in ammonia, we have another molecular compound. So let's test it out. And you can barely see that the light bulb is barely turning on, very, very dim. All right. So those are our results. And what we'll do is we're going to do some more tests, and then we are going to build a table with all of these results. Okay, students, what we have here is we have a set of ceramic plates with wells in them, and we're going to use them to test the 6 items that we tested for conductivity in the previous example. So we have water, we have sodium chloride solution, sodium hydroxide, HCl, vinegar, and ammonia, all of them dissolved in water. We're going to do 3 tests. The first one we're going to do is called the litmus paper test. Litmus paper is a paper that has been coated with a special chemical that changes color in the presence of a solution that has acid or base in it. We're going to test it out. So we have pink litmus, blue litmus paper. And then what we're going to do here is I have put samples of each one of our items in these wells. And what we're going to do is we're going to drop a little bit of phenolphthalein, which is misspelled in here. I'm sorry. This is phenolphthalein. It's hard to spell. I'm sorry about that. But here you go. More or less, phenolphthalein. It's as hard to pronounce as it is to spell. But anyway, we're going to test also that indicator chemical against our different samples here, okay? So let's start out with the litmus paper. I'm going to start with water. And what I'm going to use is a stir rod to hold it just a little drop. And I'm going to put a drop here onto the pink litmus paper. And then we're going to put another drop against the blue litmus paper. And of course, the paper gets a little darker, but it doesn't change color. That's not what we're looking for. All right. Let's test out the NaCl solution, sodium chloride. Start out with the pink litmus paper. And then do the blue litmus paper. Oops, sorry, apparently I had 2 of them in there by mistake. Okay, there you go. Apparently I had 2 pieces of litmus paper stuck together. Again, notice that it does get a little darker because it's getting wet, but that doesn't represent a change in color. So let's try out the NaOH first against the pink litmus paper. Again, we're just going to put a drop in there. And see, you can see now a real color change. Let's try it against the blue litmus paper. And as you can see, all it does is it gets dark because it's getting wet. But you see a significant change in the pink litmus paper versus the NaOH. Let's try out now the HCl. First against the pink litmus paper. And again, we don't see any significant change other than it's getting wet. Let's try it against the blue litmus paper now. Oh, that's a significant change. As you can see, it turned pink. Actually, almost red in color. Okay, let's try out now the vinegar. Remember, at this point, although you probably know, we don't really know what vinegar is, but most of you know what vinegar is anyway, chemically. Let's try it out against the pink litmus paper. As you can see, there is no significant change. Check it against the blue litmus paper. Oh, and we see a change to the color pink. Okay, the last one we're going to check is the ammonia. First against the pink litmus paper. As you can see, it turns it blue. Then against the blue litmus paper. And again, it turns it nothing. There's no change in there. So I'll have a picture of all of these posted in your PowerPoint or your video, whatever format we end up doing this in. So you'll be able to see a picture of all these together. Sorry, students, I had a little spill here while I was getting ready for the next step, but here we go. Our last test is going to be against phenolphthalein. Phenolphthalein is a solution of a chemical that changes color depending on whether the solution has an acid or a base in it. So what I've done is I've placed in these wells samples of water, NaCl, NaOH, HCl, vinegar, and ammonia. And what I'm going to do is simply put a drop of phenolphthalein into each one. So here is water. Let's see what happens. Absolutely nothing. Let's see what happens with NaCl. Absolutely nothing. What about NaOH? Ooh, we have a pink color there, actually a very bright neon pink in there. Let's see HCl. Nothing happens there. Vinegar. Nothing happens there. Ammonia. Oh, we got the pink color all over again. So those are the tests, and what we're going to do now is we're going to go and analyze them on our digital whiteboard. Thank you so much. Okay, I hope that you enjoyed that little demonstration here. And this is a picture of what we ended up with. These are the ceramic well plates and the different reactions we carried there on the left side, and then the 6 substances that we tested across the top. The only result that is missing here is the conductivity experiment that we did. So what I've done is I've built the following table where across the top you have the different substances, and on the left the 4 different tests that we did. If you want to, humor me, pause the video and see if you can fill in the blanks here. You can use yes or no for a result, or you can use positive or negatives. I'm going to use pluses and minuses to indicate whether a result was obtained or not. So you can pause the video and then come back and I will unveil the results. Okay, thank you very much. And if you were willing to indulge me in this, here are the results. This is what we obtained. You'll notice that in some cases I used multiple plus signs to indicate that there was a more marked reaction than with the other ones. So let's start out with the first test here, the test of conductivity. Now, remember, if you have water that is distilled, such as we have in here, in other words, you remove all of the salts that are typically present in salt water, notice that there is no conductivity. Water does not conduct electricity. But it's interesting that when we put other things in there, we get that light bulb turning on very brightly. You have conductivity. Now, how did that happen? Well, obviously, something got put in solution that allowed the solution to conduct electricity. So in essence, conductivity is an indicator of the production of ions in solution. Now, some of these are fairly obvious. Sodium chloride. We know that sodium chloride, NaCl, will produce sodium and chloride ions in solution and therefore give you a strong positive test. Sodium hydroxide is an ionic compound, so it also gives you sodium ions, but the other ions are not oxygens and hydrogens, it's hydroxide ions. Remember the rules of polyatomic ions back in your earlier chemistry classes. Now, HCl presents us with a problem because HCl is not an ionic compound. It is a molecular compound. However, the result indicates that when you put it in water, it gives a very strong response. And so we had to propose their ions here. So all we can say is that probably what is happening is that a HCl, although it is molecular, it is ionizing into chloride and something we're going to call for now hydrogen ions. Now, you might remember the word electrolytes. These are substances that when dissolved in water cause the solution to conduct electricity. In other words, at the atomic level, what we say is that these substances are producing ions in solution. Now, what's interesting is that vinegar and ammonia also gave us some response, but it was a lot less. In other words, the light turned on, but it was dimmer. And so that would indicate that in these cases, although they are electrolytes, although they produce ions in solution, they are producing less ions. Okay, so we have our little scenario here. We know that all these substances produce different kinds of ions. Now let's see what they do. So I'm going to take here first the blue litmus test. So what we see with the blue litmus paper is that everything except HCl and vinegar caused a reaction. So what we would say is, well, let's see, HCl has hydrogen and chloride ions,
Well, NaCl has chloride ions, but it didn't give us a reaction. That must mean that what produced the reaction in the case of HCl must have been the presence of the hydrogen ions. So the blue litmus paper test is a test for the presence of hydrogen ions in solution. And the fact that vinegar gave us a positive result in that case tells us, therefore, that the solution of vinegar must have hydrogen ions in it. See, I'm trying to get you to analyze these things. Of course, I could just tell you these things and get done with it, but to me, it is more productive to think through these tests and analyze them and train your minds to recognize these different factors. Okay, let's look now at the pink litmus, and as you can see, the pink litmus paper test and the indicator test, the chemical indicator phenolphthalein, both gave the same results. In other words, only the sodium hydroxide and the ammonia gave us a positive test in both of those cases. Once more, what is in there? Well, sodium hydroxide has sodium ions and hydroxide ions, but NaCl also has sodium ions and didn't give a positive test. So that means that what is causing this reaction must be the hydroxide ions. And so both the pink litmus paper test and the indicator are tests for the presence of hydroxide ions in solution. And since the ammonia gave us a positive result in this case, it must mean that, again, at this point, whether you remember what ammonia is or not chemically, we know that in that solution there must be hydroxide ions. Okay, so I hope you enjoyed this little review, this little journey through days of old and things that you probably learned before, but I figured it'd be worth the time. Now, if you decided to skip it, that's fine. Just go on to the next video. Thank you.